Here we're given a to the power of b over 4 equals 16, and we just want to find one possible value of b. So when you're looking at this, you might be tempted to sort of use your knowledge of exponent rules to sort of rewrite this, but I don't think that's the best approach. I don't think any sort of complex math here is really the best approach. The point, we just want to really rewrite 16 as something to the power of something over 4, right? So, for example, let's just take the smallest thing that we can have for a for 16. So we can say this is equal to, or let me do it a little bit separately here. So 16 is equal to what? Let's say 2. 2 to the power of what? Well, 2 times 2 is 4, times 2 is 8, times 2 is 16. So 2 is equal to 2 to the 4, right? So now if you make this equivalency, you're basically, let's now rewrite this as a to the power of b over 4 is equal to 2 to the 4, right? The reason I rewrote this is just so we have it sort of in the same form of some base and then to some exponent. So here we're basically saying that a is equal to 2, and we're saying that b over 4 is equal to 4. So then how would you solve for b? Well, if you know that b over 4 is equal to 4, just multiply both sides by 4, and you know that b has to be equal to 16. So that's one possibility. There's a bunch of others depending on what you make this base to be. You could, for example, you could just say, okay, I don't want to express 16 as 2 to the power 4. I want to say 16 is equal to 4 squared, in which case you'd be saying that a to the power of b over 4 is equal to 4 squared, in which case you're saying a is 4, and you're saying b over 4 has to be equal to 2. In that case, you do b over 4 equals 2, multiply both sides by 4 times 4, so then you'd say b is 8, for example. These are both correct answers.